Hi there, I hope you're having a great day. Today in this video I'm going to be programming my helicopter enemy to stick to the top of the screen, spawning either facing vertically or horizontally, flying from its spawn point to that top area. I'm going to give it a little bit of tilt and sway to make it more interesting, and finally a bit of left and right movement, so it's all set up for my next video when I'm programming in the weapon systems. If you want more game dev related content, then please subscribe to the channel, and onwards with the video. I've already imported the model into Unity and set up everything in the animator. To get both the animation on the top propeller and the back propeller to play, I had to create a new layer in the animator, and from there it was just the same as setting up the first animation. The first thing I'm going to do is create a spawn point that I can place that the helicopter will spawn in, and from there they're going to fly to the top of the screen here where they'll hang around for a bit. Make sure that the helicopter is prefabbed, and we're going to create a new empty and name this helicopter spawner. We'll set the transform to 0 and then prefab it. Create a new C# script, and I'm going to call this also helicopter spawner. Open that up and magic up some code. Okay, we have the helicopter spawner script here written out. What I want the spawner to do is to create the helicopter and assign it either to be facing the player or facing side on from the player. And here is how we do that. The variables we have at the top here, we have helicopter prefab, which is where we'll assign our helicopter. We have spawn Y and spawn X for adjusting how far away the helicopter will spawn from the spawn point. And then in void start, we spawn the helicopter. In spawn helicopter, we first make sure that the helicopter prefab isn't null, and if it is, we put an error in the log and exit out of this method. If the prefab isn't null, we carry on. We create a new vector free called spawn position, which is our transform dot position of our object. We create a bool face forward equals random dot value, and then we do a comparison of is this greater than 0.5. Random dot value will generate a number between 0 and 1. We're then checking if that value is greater than 0.5. If it is greater than 0.5, this will become true, and if it's lower than 0.5, this will evaluate to false. And either that true or false statement will be stored in this bool face forward. Down here we have a quantonian called spawn rotation. Spawn rotation is equal to face forward quantonian.identity quantonian.euler minus 90 on the Y. What this will do is if face forward evaluates to true, then quantonian identity will take over, and if face forward is false, then quantonian.euler with a minus 90 is applied. Quantonian identity just does nothing and is just the default rotation. The quantonian.euler is a minus 90 degree rotation on the Y. We then instantiate the helicopter prefab with the spawn position and the spawn rotation. And we go back to Unity and hook all that up. I've put our helicopter spawner script onto the helicopter spawner object. I put the helicopter enemy prefab into the helicopter enemy prefab slot, and I've set the spawn Y and X to 0, 0 just so we can see if it spawns directly on top of it, which is all I want at the moment. So we hit play and we should just see the helicopter spawn straight away. Yep, and it is facing towards us. Now if I hit play again, there's a 50-50 chance it will face the other way. Hey, wonderful. Now what I want the helicopter to do is fly from wherever it spawns to the top of the screen here. We'll be putting the spawn points ahead of the track so the helicopter comes and flies down onto the screen. For that we're going to create a new C# script, and we're going to call it helicopter enemy. For this script I took what I knew from CSS, and we're using padding to position the helicopter exactly where we want it. The top padding is how close from the top the helicopter will be, and our distance padding is how far from the camera it's going to be. We then have a private camera main camera, which will be our main camera. Main camera equals camera.main, so we set that variable up. We then make sure that we have a main camera and that will work. If it doesn't work, we throw up an error. We then create a new vector 3 for where the top of the screen is, which is our main camera dot viewpoint to world point, new vector 0.3, 1 plus top padding, the mass absolute of the main camera transform.position.y plus distance padding. The viewport is like a 2D map of the screen, and what this is doing is getting the position on that 2D map. 0.5 is the middle point of the x-axis. The next variable, 1f plus top padding, is the y-axis for the top of the screen, and then the mass.absolute main camera transform position.y plus distance padding is the distance that we have in the z-axis. We then set the transform.position to equal top of the screen, which is this new variable. Back in Unity, we drag the helicopter enemy script onto our helicopter, and you cannot see it because I'm in the way. And if we hit play, the helicopter should spawn and fly to the top. Right, he's up there, wonderful. Now the top padding controls, be sure that when you are testing this stuff and you are changing numbers down here, you're actually not changing it on the prefab and you're changing it on the instance that you're testing it on, which is the one that we spawned over here. So we have it up at the top there. So top padding is going to bring it closer or further away, and distance padding is going to bring it up or down. If I go into scene mode, you'll be able to see that better. So I'm going to find a number that works nicely for this. The numbers I've come up with that have the position that I want is minus 0.09 and minus 87. However, I do think this looks a bit dull with it just sitting there like that. So I want to add some tilt and sway to the helicopter to make it a bit more interesting. I'm also going to add the helicopter moving at the top of the screen. To do that, I'm going to go back into the helicopter enemy script and I'm going to magic up a bit more code. Okie dokie, we have a lot more variables in this script now. We have move speed, which is going to control how fast it moves from its spawn point to the top of the screen. We have sway amount and sway speed, which is how much it's going to sway. And tilt amount and tilt speed, which is going to control how much it's going to tilt. We have a new boolean for is at top, which equals false by default. And we have a quaternion for the initial rotation that we start with. The initial rotation is going to equal our transform rotation. This is just so our helicopter enemy knows which way it is facing. The first new thing we do in update is we check if we're at the top. If we're not at the top, the transform.position will equal vector3.move towards transform.position top of screen move speed times delta time. The first variable is our current position, the second variable is where we want to go to, and then the final variable is the speed at which we want to go there. If the distance is less than 0.1 between our position and the top of the screen, we'll set is at top to true because the helicopter must be there now. We will then begin applying the sway and tilt method. I could probably also split this into its own method, but I will do that later. In the apply sway and tilt method, we have sway, which will be affecting our helicopter's position, and we have the tilt, which will be affecting our helicopter's rotation. On the X and Z axes, we create new floats for the sway using mathf.syn and mathf.cos. We do time.time times sway speed times the sway amount, and then we do the same thing for the tilt with the tilt speed and the tilt amount. If we're at the top, then our transform.position will equal top of screen plus new vector 3 sway x, sway 0. This will make us sway while we're at the top. Else, we're just going to add that onto the transform.position to prevent us from snapping around the place while we're flying towards the top of the screen. We apply the rotation with transform.rotation equals continent.euler tilt x and tilt z times the initial rotation. Alright, jump back over to Unity. Okay, put our spawner somewhere like over here because I want the enemy to fly down onto the screen. Go onto our enemy here. Alright, so he's there, he's got a little bit of tilt. So if we up the sway amount, oh, you can see that he's kind of moving around. Up the sway speed. Yeah, he's kind of moving around in circles, I like that. Up the tilt amount, and we get some nice helicopter kind of movement on the rotation. Again, these are some settings I'm going to have to play with, but that is looking much nicer than the stationary version we had previously. The final thing I want to do to the helicopter's movement before I get on with the weapons is just making it move left and right at the top of the screen. So one more time, I'm going to jump back into the helicopter enemy script and magic up a bit more code. 4 new variables here. We have Z move speed, Z move range, both as serialized fields. Move speed will be controlling how fast it moves left and right. Move range will control where it can move left and right. We also have Z direction and Z start position. Z direction will be controlling whether it was going right or it's going left. 1 being it going right and -1 being it going left. In the update method, once the helicopter reaches the top, we are setting the Z start position to equal the transform.position, and then we start running move along Z axis. The reason we are using the Z axis is because if you go into Unity, you can see here, looking down at Unity from here, the helicopter will be at this top point here, and it'll be moving right and left on the Z axis. That's why we're using the Z axis for this. In the move along Z axis method, we're declaring a new float variable which is equal to Z direction times Z movement speed times time.delta time. We then create a new vector 3 new position, which is equal to the transform.position plus a new vector 3 with Z movement being on the Z axis. We then set that new position to be our helicopter's position. We then go into an if statement if mathf.abs, which will return the absolute value of a float. We have transform.position.z minus z start position.z. This is the distance that the helicopter is from its start position. If that is greater than or equal to the z move range, then set the z direction to times equals -1. This will then flip z direction, so once the helicopter gets all the way to the right, it will then start going left. Let's jump into Unity. He flies on screen and he should move all the way to the right and all the way to the left. Nice. We go into his variables. We can change the Z move range. If we up that really high, you can see him going all the way over there on the left and then all the way on the right. Although it does seem to get a bit janky. It does seem to get a bit confused at very high numbers, but this in itself is a kind of a pattern that could be used. So we change the move range to have different range of movement. What I'll probably do is make it so that the Z move range is a bit more random, so it's not always spawning at the top middle here, so it's a bit less predictable for the player. I also need to make the player model a bit bigger. Well, that's the end of this video. In my next video, I'm going to be programming in the weapon systems for the helicopter. When it's facing this way, I want it to use rockets that home in on the player and explode. When it's using the side cannon, I just want it to keep on shooting while rotating side to side to create a nice kind of pattern for the player to dodge while shooting at it. So if that sounds interesting to you and you like game dev content, then please subscribe to the channel and please like the video. Leave a comment with your questions or your suggestions for the game. And that's it. I hope you have a great day. Thank you for watching.